viewers, we are the Network and Critical Infrastructure Security Research Group, abbreviated as ERIS, the goodness of chaos and discord, both relevant for successful research. Our group covers security and privacy of networks at all layers. Beyond, we investigate security and privacy in large-scale infrastructures that are critical for society like mobile networks or the power grid. At SBA, we love to conduct high-quality research with high practical impact for society.
I'm interested in measurement studies affecting privacy technologies, net neutrality, and anonymity. Right now, I'm working on the future of online anonymity, especially for the Tor network. Besides measurements, I looked in how to improve the Tor network. With the support of SBA, I co-founded a non-profit organization, the Foundation for Applied Privacy, that is hosting Tor exit relays. We now serve 600 megabytes per second. That is 5% of Tor's total exit capability and Austria's largest exit node.
Mobile networks, what would we do without them? Among others, we are developing a measurement framework, significantly easing live experiments in mobile networks. And we also investigate how fake base cells erected by adversaries can be detected.
My LTE telescope passively scans for LTE and GSM signals and collects protocol information. This information is invisible for existing smartphone applications, but not for our software-defined radio. Further, a parabolic dish on a rotator allows us to explore location estimation based on signal strength and antenna direction. With this approach, we investigate how networking parameters could be used for the detection of fake base cells, and indeed, we have already identified that network operators show distinguishing behavior in paging and messaging.
Existing measurement platforms are built for traditional fixed-line connections and do not reflect the requirements and objectives in the mobile field. For instance, we deal with metered connections, international roaming traffic, or zero-rating offers. In order to fill this gap, we created Mobile Atlas, an open and extendable framework enabling scientists to conduct qualitative and quantitative measurements in a controlled environment. By now, we have deployed measurement probes in 6 European countries and are able to conduct measurements practically all over Europe from our office.
The power consumed by internet-connected devices steadily increases. In my work, I have shown that a botnet of zombie computers is able to destabilize the European power grid by increasing the zombies' power consumption all of a sudden in a coordinated manner. This behavior can result in blackouts. Also, an outage of or an attack against the Bitcoin network might lead to the same consequences.
Our original model of the power grid was too coarse-grained to develop more targeted attacks. So I modeled the Austrian power grid in more detail based on a wide range of accessible open-source geodata from the OpenStreetMap platform. In a geographic information system, I processed power lines as well as power stations and substations and clipped them with spatial data, such as the municipalities, in order to link the information with each other.
Our successful modeling emphasizes that the security by obscurity approach is inappropriate for critical infrastructure protection. With this more fine-grained model, we will now focus on structural and topology-related risks.
We will first use our different types of centrality measures, such as betweenness or eigenvector centrality, in order to perform a structural security analysis of the Austrian power grid. Moreover, we will conduct a flow-based security analysis that considers the actual capacities of Austrian power lines. This second phase includes a simulation of different attack scenarios. On the one hand, our analysis will help identify potential effects of targeted attacks on the Austrian power grid. On the other hand, it will also allow for comparison which type of attack is most severe and how such attacks relate to problems resulting from component defects that appear out of natural causes.
The Internet is currently undergoing a transition. IPv4 is replaced by its successor IPv6, and this leads to distinct consequences for operation.
It is my goal to enable internet-wide IPv6 measurements, as they are important to gain insight into the deployment status of the Internet. However, current IPv6 scanning methods are limited, as they rely on hit lists. Our approach is able to infer the deployment status of a remote network by relating error messages instead of positive responses. In course of our measurements, we also detected widespread misconfigurations in the IPv6 Internet, particularly numerous routing loops.
In the future, we want to combine our measurement research with our power grid expertise to further identify IT infrastructure that is able to destabilize the grid. Last but not least, we investigate how software-defined networks can be used to make networks more efficient.
I conduct research in the IoT with a particular focus on secure communication for applications in aviation, critical infrastructures, or the smart home. Currently, I focus on coordinated and resource-efficient communication and high granular access management. Thereby, network virtualization plays a key role as it provides an overview on the current network status and allows to react, for example, in case of congestions immediately. At the moment, we investigate how a software-defined radio-based controller makes communication even more efficient.
We, the ERIS group of SBA, conduct diverse research to secure networks and critical infrastructure, including future internet protocols, anonymity networks, the power grid, network measurements, software-defined networks, and mobile networks. We hope you enjoyed your virtual trip to Vienna. Bye!